Hello, ladies and gentlemen. Today we are going to begin Chapter 3, which is evaluating properties. And so lots of things to go on today. I have a PowerPoint that will help us go through things. I don't really like PowerPoints, but today I think PowerPoint's going to be helpful. We're going to go look over the appendices. I have there's some notes to write. There's a lot of things going on. Also, you'll see posted that I've released Chapter 3 information. I have released some documents that might help you in evaluating properties that you can review. I'm also have a test study guide that's out there and some practice tests from the past few semesters. So lots of things for you to access, for you to work on when you're over this long weekend. Because I don't know what else you're going to do over the long weekend except with thermo. But remember, Wednesday's homework is going to be due on Wednesday of next week. Today's homework is due on Friday of next week. And then we're going to come back and have the exam. And I promise that after the break, we come back next Wednesday, I'll know exactly how I want to run the exam on Monday night. Not next Monday, but in 2 Mondays from now. So it's coming up pretty rapidly, but I had to figure out how to do this this remote and hybrid and all that, and get that so it's fair to everybody. And so I'm working on that and making sure that it's all good. It's all even. It's as even as I can be. I probably won't be able to be perfect, but a lot of consideration is being made in how to help you through this process. Okay, before we get there, I want to share you this. This was sent to me by a student, and it's an image, and it's talking about units. Okay, this was units here. They're ordering green beans from Dillon's, and this is a click list. It says, I ordered 1 pound of green beans. I received 1 green bean. This is honestly the most hilarious thing. The entertainment value of seeing 1 sad, lonely green bean in a large produce bag more than makes up for the lack of the remaining green beans. Note, on the website, green beans were added by the pound. Even though my order contained 1 pound of green beans, my receipt shows that I was only charged for 0.01 pounds of green beans, presumably the weight of exactly 1 green bean, for a total of 2 cents. So I paid a very fair price for my single green bean. I have remaining questions. Who was this order? Was the pound unit absent? And why did they really think a customer wanted a ClickList employee to so painstakingly pick out the single green bean for them? What kind of sociopath would order 1 green bean? Do you consider that calling police on that person? Obviously, I don't expect to answer to all these questions, but they're honest questions I have. Units. Units are very important. Units of green beans. So I just love that. So I was going to share that with you, and I just laugh every time I talk about it. But here today we're going to talk about evaluating properties, and again, this is where I believe that the material in this class takes off. And you may not feel that way after you watch this lecture. You may feel like this lecture is fine. There's nothing wrong with this lecture, and that's correct. We're going to talk about some very basic ideas. But what we do in this chapter is take away information from you that we normally give to you and ask you to find it yourself. So you're going to have to learn that process and learn it quite well. There will be 25 points on the first exam that comes from this material. Okay? So evaluating properties, let's talk about this. So what we're going to try to learn here are key concepts, including phase and pure substance, what is the state principle for simple compressible systems, what a pressure, volume, temperature, surface is. We're going to talk about the saturation temperature and the saturation pressure. We're going to talk about two-phase liquid vapor mixtures, quality. We're going to talk about enthalpy and specific heats. We're probably not going to talk about specific heats yet, but that's coming up very, very shortly. Okay, I made these slides a long time ago. All right, and we're going to then use this to analyze closed systems. So everything we did in Chapter 2, we're going to do again, but now we're going to use it with our own property data. Okay, so repeating the material, but now with our own property data. So when you're done with today, I want you to be able to draw some TV and PV diagrams. And phase diagrams are something you have to have in the back of your mind. And then I want you to locate states on these diagrams. That's what we're going to be trying to do. That's what we'll be doing in person in the in-person sections next week. So those are all the things that we're working on. All right. I want you to be able to retrieve the property data from the tables in the back of the book, A1 through A18 and A1E through A18E. Remember, the E means English. That's all the difference. It's the same exact table that we're going to be dealing with there. Okay, so let's now talk about some things. Let's talk about phase. You've done this as this is where chemistry comes in. Phase is a quantity of matter that is homogeneous throughout in both chemical composition and physical structure. Homogeneity in physical structure means that the matter is all solid or all liquid or all vapor. Yeah, this is going to blow your mind kind of stuff, all right? So some examples that we have here are going to be the air we breathe is the gas phase, consisting of a mixture of different gases. It's going to be nitrogen, oxygen, argon, a little bit of helium, neon, some carbon dioxide, all of that together, but they're all in the gas phase. Okay? Drinking water with ice cubes has two phases in it. It's got the liquid phase and it's got the solid phase. Okay? And then we have vinegar, oil, salad dressing contains two different liquid phases. Okay, now a pure substance is a substance that is uniform and invariable in chemical composition. So a pure substance can exist in more than one phase, but its chemical composition must be the same in each phase. Right? So here are some examples. Drinking water with ice cubes can be regarded as a pure substance because even though it has a different phase, everything is H2O. Okay? The same composition. Even the fuel-air mixture in a cylinder of an automobile can be regarded as a pure substance until ignition occurs. It's that the chemical composition all the way in that gas is going to be pure. Now, I want to make a note here. I didn't really explicitly say this when we started this, but this PowerPoint is on campus. You don't need to take notes about this if you want to, because I'm going to go through some of these slides quite rapidly. That's why I'm going to use PowerPoint. I talk fast anyway. I would be writing excruciatingly very fast. I'd be writing very fast for you to take notes. So we are going to be dealing with these common substances called in simple compressible systems. Okay, and these substances include those in Appendix A2 through A18, A22, and A23. So we're going to start just go by opening these slowly up to you right now. So I want to go to my document camera, and we're going to look at our appendices, which hopefully you had printed out like I've asked you to. And when we look at these, we're going to see that our first page that we've dealt with are the chemical formula, molecular weight, this information. And we're going to start talking about table A2, which deals with, if you see here, water, H2O. A printer kind of put that off. But we're going to have water for a bunch of things. And there's a whole bunch of stuff in this table which we'll learn how to use. Notice there's going to be a conversion, a pressure conversion up here, which is going to show you the conversion between bars and kilopascals. But you have water. And then there's a bunch of tables here, and then you're going to have a refrigerant, R22. And then you're going to have a refrigerant, R134A. And then you're going to have refrigerant ammonia. And then you're going to have propane. So that's the five that we're going to deal with right now, that I really want to focus on right now. Water, ammonia, propane, R134A, and R22. In fact, they all are refrigerants. And if you want to impress your friends, and I tell you, this will impress your friends, maybe a date that you have, you can say, hey, did you know we have a refrigerant R134A and our refrigerant R22. There's other refrigerants out there that we're dealing with. But propane's also a refrigerant. It's called a R290. Ammonia is a refrigerant. You can call it R717. And here's the big one. Water is a refrigerant, and it's R718. So if you really want to impress somebody, go out to a restaurant, socially distance, everything like that. And when they ask you what you want to order for a drink, just lean back and say, I'd like a little refrigerant 718. And you go ahead and put some solid phase in that, you know. And your person across is just going to be in awe. Like, man, this person is incredible. How do they know this? And then you can just say, hey, I know, water's a refrigerant, 718, saying solid phase because I want ice. And they're going to be talking to you. And then your conversation is going to lead to thermo. And there's just I mean, this is going to be amazing. In fact, I have done this one time. I've ordered water as refrigerant 718 one time, but that was because the student was working at Panera Bread it was in my class, and I ordered refrigerant 718 for my drink, and that was, that was fun for me, but probably not as fun for everybody else around me. But anyway, I'm still gonna go with it. I'm still gonna say that's what we need to do. Okay. Now, we want to look up the intensive state of these simple compressible systems. Okay, and we're going to describe it by its properties: temperature and pressure, specific volume, which we've already talked about, not so much density, but density kind of works into place, specific internal energy, which we already talked about, and then a new idea that we're going to investigate a little bit in this chapter is specific enthalpy. Okay, velocity and elevation, we're not going to put those in the tables in the back of our book because they depend upon some datum that we have, some arbitrary datum that we have out in where we're located. And so the state principle, these aren't relevant. Temperature, pressure, specific volume, specific internal energy are. Okay. Now, not all relevant intensive properties are independent. Some are related by a definition. So I've talked to you about density and specific volume. They're defined as the reciprocal of each other. Okay? Specific enthalpy, this thing I've said, enthalpy, is internal energy plus pressure times specific volume. Now, we will not, again, I'm going to tell you the definition of this. We will start using this idea later on. Right now, we're concentrating on specific volume and specific internal energy. Now, some other things that we're going to be looking at here are developed through expressions developed from experimental data. We take some experiments, we find it fit a curve, and then we find out what numbers there are, put those values in our tables. And even others, we're going to find that they're independent in a single phase and they're dependent when more than one phase is present. So we have to understand all of these ideas for our simple compressible systems. Now, here's the kicker. For a simple compressible system, values for any two independent intensive properties determine the values for everything else. This is the state principle. When I say in this class, set the state, you are going to look for two pieces of information. And once you find these two pieces of information, we can use these tables in the back of the book correctly to find all the rest of the information about the substance. So this is just like saying we have an XY graph, and if we find X and Y and we locate it, we know exactly where we are. That's exactly what we're doing here. We're going to use two bits of information on a chart. We know exactly where we are. We can find everything else from that. That is what we mean by setting the state. We typically are going to do this by either using temperature and pressure is what we're going to use typically. And we're going to have two very commonly used charts that we're going to use, TV and PV charts that we're going to use to do this. Now, their temperature and pressure is not always an independent set that we are going to deal with, but we're going to use TV and PV charts. Okay, so I think that's where I want to go. Yeah, I'm going to pause here, and then we'll continue next to talk about this PVT surface.